Hey everybody, Zach here, and welcome to the fifth lesson in this RTS tutorial series. In this lesson, we'll be iterating our movement controls and updating them to respond to the issue we found last week. In addition to this, we will be also adding a sort of movement speed modifier to make our camera movements faster when the user holds down Shift. So without further ado, let's get right into the lesson and join me in the Unreal Editor. Okay, so here we are back in our template, and just want to review what the bug is. So we have a few bugs. The one we're dealing with is, if we go forward now, hit W, we go forward, hit up key, same with S and down. I'm going to go left, A, or left key, D, or a right key for right. But if we change our axis orientation, so our camera is currently orientated, look down the x-axis. If we change it by panning to the y-axis, and we hit, this is our new forward, and we hit W, we still go down this axis. We hit A, we go down this way. So let me see if I can get this back to where I want it. It's always a bit of a trick to do. If you're doing a top-down sort of map-based RTS, like Civilization, which I realize isn't an RTS, so think Hearts of War, then this camera isn't a bad setup. Just got to get to the pan controls. So what I want to do while we're here, so I just want to zoom in for a second, and I want to just sorry, I have to think about what I want to do there for a second. So I want to bring it there for a minute. And I want you to see as we rotate it, we aren't rotating around the sphere is moving with us. So clearly the sphere is rotating. There is some component, either the movement component or the controller, that isn't rotating. So there's a few ways to address that. We can address how we've done the rotation. We can address how we've set up, how we set up the controller, how we set up the pawn itself. There's a few ways to address it. What we're going to do is we're going to address our setup within the controls themselves with regards to movement. So I'm going to stop the simulation, stop the test, and I am going to deal with the stuff in here. Now, before we really address that bug, I want to do some house cleaning. I made a decision, and this isn't my first time recording this lecture or lesson. I said that last time too. But at the end, I decided at the end of the last recording I did of this, we had some massive issues in it where it didn't get all the sound, which is to say I got none whatsoever, that I didn't like this setup, and I'm going to, keep it like how it is over here. And I'm just going to be smarter about this. I'm going to delete the is pressed, move that down there, disable camera into pressed, and disable camera not true into released. Take that is pressed here, and that branch, if I can get it to select, there we go, and delete both of those. I am then going to just drag off the mouse Y, our gate, and from our exit we'll go into our set actor rotation, and we will grab from our pressed through set disable cam as true to open, and set to false to close. And we're just going to grab everything here. Everything before the set movement. We're just going to drop it below that line. We're going to do the same with the actual commands there. Just bring it there so it's a little bit neater. Drag this out just so it looks a little bit more symmetric. I know I'm being a little retentive. That doesn't really matter. Alrighty. In terms of ease of readability, there we go. I'm also going to highlight everything on this side, drag it down slightly, and comment it out as pan Y, because that's where our pan Y controls are. I'm going to grab everything up here, drag it up slightly so I don't get the part in the middle, and that's our pan X. I'm going to close this back up. I'm going to close that back up. And I am going to then grab these two, just drag them down here. Grab our pan reset, grab that, and not try to rename it, and put it there. And I'm just going to comment all of these out as pan controls. And we are completely done with these. If you have a different way of doing it and it works, that's fine. Go ahead and use it. That said, be mindful if you change this to address the issue, then you don't need to change what we're going to do here. So yeah, let's address the movement issue. So now that I've done that, got some more house cleaning to do. We're going to delete this boolean, because we're not using it anymore. So I'm going to compile and save, and I'm going to start the fix. But as I start it, you're going to see I'm going to run into a small issue where I'm missing some variables we'll have to add in. So let's first just drag these over here, because we're going to need a fair amount of room. Probably not that much, but still, nice to have a little bit extra. And you know what? We aren't going to use this, because this is part of the issue. As I said, the issue is either going to be in this, in the panning, or in the camera pawn itself. And to be fair, this is what I found to be the easiest fix, and the one that has a less sort of alternative issues that arise as a result. So let's delete those 3 parts. Should be 4. I did this on last recording too. I forgot to delete that reroute node. And instead, what we're going to do is we're going to drag off the camera pawn reference, and we are going to either set the actor transformation, or the actor location. Either one of these will work. There are just some minor differences in what you, which end node before you get to this you'll have to include. So if we use set actor location, which is the one we're going to use, we will need a vector. However, everything up until that point remains the same. If you do the set transformation, you will need a transformation node, or at least something that has an output that allows you to pull off from a transformation. We're going to need this twice, just like before. So I'm going to duplicate it. And just like before, this is going to come off the false line, because we want it to be when disable camera is not true, so the camera is not disabled, we want movement to occur. And we're just going to add in a reroute onto that, drag into the target and into our false, and if we hit play, nothing is going to happen. The reason nothing will happen, so I'm just organizing as I talk to you, the reason why nothing will happen is we don't have a new location for it to go to. We haven't told it where to go. So before, in our last setup, we could have very easily, said, we did very easily say, take this value and plug it into there for the change. Well, now we need to think about that in a different way. We need to take off this value, which by the way is 1 or -1, so W is 1, S is -1, A is 1, D is 1, A is -1. We need to come off of these and add them and take these and somehow convert them into a location. So what we need to think about, you can either think moving forward, how do you turn a float into a location or a vector? Or how do you turn a vector back into a float? Now, we did this before. If we just simply split the structure, we have 3 floats that make it up. You could literally probably just plug that in there. And in fact, let's see what happens when we do that. We're going to plug that in, and I'm just going to compile and save, and nothing happens. Now, I do kind of wonder if it's due to another issue I know about, so I'm just going to plug this into the Y, compile and save, and try it. Yep, nope, nothing happens. So let's unhook that. Ooh, unhook both of those. So we need to find a different way to do that. So if you right-click on any of the parts that made up that vector before, you can do recombine struct pin or structure pin, and you'll get your original pin back. So what are some ways to do this? And we also need to think about, we are moving locations. We need to think about what our current location is. So we need to get our current location. But, and this is the thing that we need to really kind of recognize here, is it isn't just the location that matters. Location is just our X, Y, Z vectors. It's those 3 floats fitted together. There's a lot more we need to worry about. we need to worry about our rotation, which is another set of x, y, z vectors. So in terms of thinking about that, if we just simply go some room, because we're going to be dragging off that node in a second, we drag off of this, we can get actor transformation, or transform. And transforms are made up of, and yes, we're going to do it down here as well, are made up of our vector, our rotation, and our scale. That last one we don't really care about, at least right now. We'll talk about scale down the line as we get into some of the other things we need to consider in RTS. So we have in here everything we need to actually address our issue. So when we get our actor transformation, if we get its rotation, we can set the movement to follow that rotation. So let me just hit compile for a moment. I know this isn't going to work, but when we pan the camera, by the way, you might notice the sphere is missing. It's actually still there. It's under the map. And that has to do with how set actor location works. I've not quite worked out what it's doing to get it to do something like this, but yeah, it's doing that. So when we do this, and then we hit forward, well, nothing will work right now because nothing's plugged in, it's now going to, we now can tell it this is the direction we are on purely from this. Well, not purely from this, but purely from the data that we get from this. So we need to figure out how we're going to use this, though. So I'm just going to drag that down here for a moment. We need to figure out how to get this and this together. So to do so, let's just think about what we need to get. We need to get that direction. So let's type in direction and see what comes up. We have inverse direction and transform direction, or inverse transform. We want the actual direction it's currently in. We're not doing a flying sim with inverse controls, so transformation direction. From here, we're already plugged into the T. We want to tell it what direction to go. And in these three, we only really care about one of them. We only care about that x value. So we could break this. We're not going to. Instead, what we're going to do is we're going to pull back from here, and we're going to make vector. And what we're putting into this vector isn't our y and our z. It's our x. We could plug this into x, potentially. But I will tell you, I've done that, and it doesn't work. One of the earlier iterations I did involved that. If you want to try it out to see what the effect is, I highly encourage you to do so, just so you can learn a bit more. I don't want to spend time doing it. But yeah, I do say, pause this video right now and try that actually. When you're done, take the return value, plug it into there, or come back, do everything we're going to do, unplug what we'll have over here, plug this into X, leave what will be over here the same, and try it, just to see what the effect is. So in my original iteration, I got this far, and I plugged the axis value in, and I went over here and did the rest. But and knowing that isn't going to work, I'm not going to walk you through that exact iteration. Instead, what I'm going to walk you through is getting this x to work correctly first. And for that, we're going to need two new variables. And we are going to need one that's, our default, let me type, sorry. Default movement speed, which will be a float. And we are going to need one that is our another float called movement speed modifier. And we're going to compile both of those. We'll set our movement speed modifier default value to 1. And our default movement speed value to 15. I have based this off the size of the spring arm I'm using. Had I set the spring arm to 2500 instead of 1500, I would set our default movement to 25 instead. We're going to come back to this, so we can do this in a different way as well. So this is how fast the camera moves. And we're just going to plug that into, not plug it in, move it into our movement variables. This is modifies the default movement speed. The reason why we used 1 is we're going to use multiplication, and anything multiplied by 1 is just itself, so it's useful. And we'll move that to movement variables. Right now, this variable has no functionality. We'll actually do that next. So just compile, so we have that stored in there. And off this x value, I'm going to drag back, and I'm going to do float times float. And I am going to take my movement speed modifier, and I'm going to plug it in there. I'm going to come off this top part and do float times float. I am doing this backwards intentionally, by the way. I'm doing this the way in which I worked it out, minus having done this part first, and trying using the axis value. I am just literally going through this process I went through. So I'm just going to grab these and drag these further back because I need that room still. Take the axis value, plug it into the top there, and add our default speed in. Now to explain what's really happening, when we hit the forward or W or up or down or S, the number goes through there. It gets multiplied by our 15, so it becomes 15 or -1, because this value here is 1 or 15 or -15, because this value is either 1 or -1, and this value is 15. Our movement speed modifier then modifies the speed. Right now it has no functionality, so it leaves it at whatever comes out of here. And that becomes our new x vector. We take our transformation, we get our direction, and now we get the x vector in that direction. So once we rotated the actor, it's facing a new direction. We are saying, in this direction, go this way this much. Except we're not done yet. We have to get the original location. We don't have that. We just have the direction right now it was facing. So we need to get the original location, and to do so, we're going to break transformation. And you notice we get some things we don't need. Hey, we have rotation again. That's kind of nice, but we want to leave the rotation. We don't want to set it, so we're going to just pass that through. What we want to change, however, I'm going to make my life a little bit easier. No, actually, I think it was better the other way around. What we want, however, is to take our return values, which if you notice are both vectors, and add them together. So I'm going to drag off of this. I'm going to add it. Vector plus vector. To make my life a little bit easier, I'm just going to move that pin down there. Plug that pin in there. And, hey, we now have that set up. We, as I said, don't care about these. We're not changing them. We are changing our location from this location to this new value. And we can plug it into here. And we have now mostly finished our forward movement. There are going to be some issues with it. We'll come back to that in a minute, though. I would say don't test it, because you do. If you hit compile and play, you come here, nothing's going to happen if you hit forward. You kind of get stuck. Yeah. And the reason you get stuck is without the code down here written, it just doesn't work. So let's just highlight all of this. Let's copy and paste it. Let's drag these out because we know that we're going to need that room. Just lower it a tiny bit. And let's drag these in here. Before we plug anything in, there's an issue with this code. And it's center screen right now. If you haven't worked out what that issue is, outside of the fact that the target hasn't been plugged in, the main issue outside of that issue, which is a fairly big one, is we are still saying the same thing as above. We actually need to change what axis this occurs on. So we want to affect the y-axis, because we're now doing left and right. Now we can don't drag the actual node up there, drag off the pin into new location, drag off the reroute, plug it into our actor there, drag this way, and plug this in. Hit compile, play, and let's see if our controls work. Oop, it might help if I click on the thing. Forward, backwards, left, right. And if we pan, and our left and right are in the right area. Now, I am going to show you two bugs. You kind of already seen one. If we kind of go back to this angle and we do that, you can kind of see there's... And by the way, our sphere is back, by the way, if you haven't noticed. You can see there's some issues. If we go forward... Oh, there we go. Wait, the orb is gone again. No, I want to reload that and take a look at something real quick. The orb is already there to begin with. Okay, so I'm just going to angle it down. We're going... What's the issue is when we pan the camera, we are setting a new direction. The camera just is pointed slightly upwards due to that rotation. Remember, the sphere is rotated, not the camera. The camera has no rotation. So when we're here, the sphere is actually pointed slightly upwards. So if we hit W, we're going to go at a slightly upward direction. Now if we hit S, and we're faced that same way, we'll go down. If we hit S in this way, we should actually go up and backwards, which is kind of weird. Let's see if that actually is true, because we're going down right now and forwards with W. Yeah, that's up and backwards with S, if you're looking down. So there is clearly an issue there. Now, I was kind of hopeful this issue would show up first, but let's resolve this. So if you want to think about it, the issue isn't on the x-axis. We have no problem there. It isn't on the y-axis. Well, we do have a problem there, but it isn't related to this particular issue. The issue is our z-axis, our z-axis for the Americans out there, my fellow Yanks. So let's change this to 100, just to see what happens. Let's limit it to 100. I'm going to tell you it's not going to work. We have a rocket ship! Let's hopefully get that timing right. So what's happening here is every second, because it's always checking for this, it's setting our vector on our forward movement as 100. So it's going up 100 every tick. Let's set that back to 0. What we really need to do, actually, is to limit it on this side. And actually, you know what? Yeah, no, we need to limit it on this side. To do that, what we need to do is we need to come off of here. We're going to drop that one. And we are going to make transformation. We aren't changing the original rotation, and we aren't changing the original scale, so those just pass through. We are changing the location from our original location to our new location, as determined by this part of the code here. It goes into our make transformation. We are going to, of all things, break this transformation. I will say this one took me a while to work out, and at least watching 2 RTS tutorials and 2 FPS tutorials and a whole bunch of different things on camera controllers and camera movement to work out the best way to do this, at least the way I found the most reasonable. There are a few other ways to do this, by the way. And when I say a few others, I mean, I think there's like 15 different approaches I came up with. Out of those, I piloted 4 that worked, or I could get to work at least. This just happened to be my favorite. So I'm going to break this vector. And the reason why I'm doing that is, you know, I don't care about the rotation. I don't care about the scale. I just want all that information to come through here, so that I'm getting whatever the system is getting at this point. And then I want to address the location, the new location. So I am going to drag off of here, and I'm going to make vector. So I've broken a vector, and I'm going to make it. The reason I'm passing the x through is we've already set up here on this part what our new x vector is. Down here, you know, in relation to our old x vector, we don't need to go, hey, you know what, you probably need to change it here. We've already done that. We don't need to pass through the y because we're not doing anything with the y. With the z, however, we need to limit it. So let's just limit it to 100. Just to see if it works. Actually, I'm going to do 150. I'd actually probably do 111 based on the current map setup. And the way why I'm saying that is, sorry, no, 125 actually. I want it to be above the ground. Gonna compile, gonna save, gonna hit play. Sphere is gone again, which sometimes happens. Pan is still working, but let's look upwards. If I hit W, oh, I'm going forward. I'm not going down through the map. My sphere is already down through the map, as you can see, as we come through on that side. Oh, it's actually higher up than usual. You know, I'm curious. I'm going to set this at 200. And in a second, my Visual Studio will open. Oh, or not. Compile and play. Yep, there we go. There's our sphere. So let's leave it at 200 just because then we are at a better height. Zoom out. Move. Awesome. So our movement controls are working. Kind of. I'm going to zoom in real close for a minute. We go forward. We have no issue. We go... Let's actually zoom out. We go forward, no issue. We go left and right. It looks like there's no issue, but there's actually, ever so slightly, a little bit of an issue. And in fact, it's a little bit more noticeable when we add some functionality into that movement speed modifier. So let's just save this real quick. Let's go back to our main window. Let's click Settings, Project Settings, and we're going to add some functionality to that movement speed modifier. In our action mapping, let's add a new one, and let's call this the Make Fast button. I'm joking. We'll call it Movement or Speed Modifier. And we'll give it 2 keys. I'll type in Shift, and I'm going to select left shift, and I'll type in Shift again, or shy, whatever that word was, and select right shift. Again, no need to save. Close that window out. Go back into our controller, and I'm just going to find a place a little bit above that forward movement and type in speed modifier. And when it's pressed, the speed modifier is going to change to 2. So it multiplies whatever value comes out of here by 2. And just make sure I use movement speed modifier, not the default movement speed. Alright, that's right, 1. And off released, it's going to go back to 1. You never want this value at 0, and you never want your default movement at 0. That will stop the pawn from moving. Hit compile and save. And now when we hit forward, we go that speed, back to that speed. We hit shift and forward. We're going way, way faster than I wanted. So we'll change that number. If we hit A and D, you can kind of see the issue a bit more on the A and D side now. If you look carefully, they just keep doing this. There's a bit of jerkiness there in its motion. And I don't mean in the orb blurring like that. That's just happening because it's moving quite quickly. You know, let's go here for a minute. And it's much smoother the way the camera moves. In fact, if we rotate it, we're using A and D on this side. Sorry, let me get a little bit more even so we're going to more of a straight line. Sorry, still not in a perfectly straight line. You kind of can start to see the issues again in there in terms of that jerkiness as compared to in this direction. Now, in other iterations I've done of this, that jerkiness has been much, much more pronounced and much worse. It took me a bit to work out what to do. So the first thing I like doing is adding the sweep. And in fact, this will address an issue we're going to have down the line. Without it selected, we're going to have issues triggering overlaps. You said, triggers overlaps. Please note what it says at the end there, because we're going to run into a bug. If you note what it says at the end, you will save yourself a day working out what that bug is, because it will tell you. It comes up in 2 lessons, I believe. So, yeah, note that. Remember that for in 2 lessons. I think it's 2 lessons. God, just watch me get this wrong on the on this video, like I did last video about how many lessons we had left in this section. To give you an answer, it's going to come up in the map boundaries one. So that sort of jerky movement, the way I found addressing it is actually sort of reversing our setup here and leaving this as is. We are going to unplug our movement speed modifier. I'm just going to move it over here for a second. We're going to unplug our axis value, and we're going to unplug the 2 multiplication nodes from each other temporarily, and then replug the multiplication node into that lower part. movement speed modifier into there. Doesn't really matter actually what slot it's in. I just think it's better there because, you know, the pins don't cross, even though they did just cross there. Speaking of which, so just move that so they're not crossed. And that addresses our movement. And in fact, we are done with our movement for the most part. You know, you can go ahead and comment this out and leave it. But I'm going to do one more thing. One very minor thing. But, you know, I just like it. It makes my code look neater. It, you know, cleans up some of the clutter. I'm going to highlight everything except for the disable camera boolean and the branch. I want those not highlighted. And I'm going to right click this, and you'll see we have a few options. We don't want to delete it, we don't want to cut it, copy, or duplicate it. We either want to collapse the nodes into a single node, which is not going to work for this, or turn it into a function, which is fairly common, or turn it into a macro, which is also fairly common. The major difference in terms of functionality with this code between a function and a macro is that a macro allows for multiple outputs, and sometimes that is useful with movement. Sometimes. Really doesn't matter in this case if you use macro or function. I just find macro tends to run better, especially when we replicate the controls on server for networking on multiplayer. So I'm going to collapse it to a macro. And all that code gets reduced down to these little bits, just these 4 little inputs here. But those inputs are really, when you read them, make no sense. You know, if you look, we have execute, execute to A, and A2. Well, what are those? You know, if you put our, if you put our cursor over the pin on the top execute, we can see it goes into our move forward. So you know what I'm going to do? I'm going to rename this our move forward. Or actually, I'm going to name it forward movement. Which means this other execute must be our right movement. And so that first pin goes up to our access value on the movement forward. So I'm going to name this access value X. And then access value Y for the second float. Now, I'm not a huge fan of it going forward, right, forward, right. I'm going to move my forward float up 1. So if I look at this row, there's this up arrow here, I click it, and it moves up 1, and now we have movement forward, X value, movement right, Y value. So we're a little bit more in line. We have our conditional statements on the outside, and so we can just, move things around so it looks a little bit neater. So let's just do that. And we're just going to plug that down, put that down there, put this guy here, grab that, and did not mean to do that. Now you can make it look however you want. I forgot to do one thing with this, which is something really stupid. I forgot to name it. So this will be our basic. Oop, I am having a butterfinger moment there. Basic movement controls. I'll add this to a category that I'll call movement. Oh, by the way, it says on play here. To do that between the 2 recordings on doing this. All I did was create a new category called on play. It just has reference cast from the first lesson. So in terms of what this does, basic movement control, that was not the name of it. Whoops. So the recording device I'm using is having some issues. Sorry about the jump there. All you have to do is click it, put the new name in. If for some reason you can't get it to let you change the name, hit F2, and that's what caused my issue earlier. You should be able to change the name. F2 is the default for stop recording on this system. No wonder I ran into that issue. So all you gotta do now is set this up, comment it out, and we're pretty much done. Now, I'm gonna comment this out as well. We're gonna name this, movement speed set movement modifier, which would help if I spelled modifier right, I guess. Wait, did I spell it right? I'm now having a special moment where I can't remember if there's 2 I's or not. If I spelled that wrong, I'll fix it at some point. So yeah, we've set up pretty much everything we need. I'm going to move this a bit closer. Put that there. Raise that up just a tiny bit. There you go. And make this yet smaller. And we just have one more thing we really need to add before we can finish out our basic movement controls, which will be our pan scroll. We also, however, have to deal with a bounds issue. So we're going to compile, save, and, we are done, actually. Everything we're going to do in this lesson is done. If we go back to our main part, we have everything set up. Our movement controls are working. We're able to move around our map. We're able to zoom in and out. We're able to pan. We're able to change direction of the controller. Everything is now squared away. So for the last two parts of this section, we will do edge scrolling. So we'll move our mouse to the edge of the screen, getting this to automatically move on its own. And we will deal with this boundary issue where we're able to cross outside of our play area. That said, as always, likes are greatly appreciated. It lets me know that I'm bringing you content that you value and that is helpful to you. Likewise, comments of any sort, things you want me to include, things you want me to change, are useful. That way I know what you want me to do in the series. Some of the comments might lead to some discussion with regards to like the comments I've received about dropping the introduction part I do. Some people said they want it, some people said they don't. So, again, open discussion on those sort of things. So please feed back to me. Please let me know what you're looking for. And as always, remember to hit that subscribe button and the notify bell so that you know when the next tutorial is out. And as always, I hope you have a lovely day.